Good morning all of you. This is Suresh, Faculty of Mathematics, working in Trinity Junior College. Students, welcome to Trinity online classes. We are discussing the topic quadratic expression. Already we have discussed so many problems on IPA as well as objective mains model. Now we will continue with the objective problems. If alpha comma beta are the roots of the equation x square plus px minus q equal to 0 and gamma comma delta are the roots of the equation x square plus px plus r equal to 0. Here two quadratic equations are given. Alpha beta are the roots of this equation x square plus px minus q equal to 0, and while gamma delta are the roots of the equation x square plus px plus r equal to 0. Then what is the value of alpha minus gamma into beta minus gamma into alpha minus delta into beta minus delta? He was given, we have to multiply these all four products, and there you have to replace the necessary values. So sum of the roots, so alpha plus beta if we get, then we have to take from the first equation, alpha beta from the first equation, gamma delta is the value of the second equation, and gamma plus delta is also the sum of the roots of the second equation. Whatever the values are required, we will take from the particular equations. For alpha beta relation, we will take from the first equation, gamma delta relation we will take from the second equation. Since alpha beta are the roots of x square plus px minus q equal to 0, then sum of the roots alpha plus beta is equal to, from this equation, minus p, and product of the roots alpha beta is equal to minus q. And while comes to the second equation, gamma delta are the roots of x square plus px plus r equal to 0, then gamma plus delta is equal to minus p, and gamma delta product of the roots is equal to r. Now calculate the values of the product of these four. Alpha minus gamma into beta minus gamma into alpha minus delta into beta minus delta. Take these two as one combination, these two as one combination. Alpha into beta minus alpha into gamma, gamma into beta. Alpha gamma minus beta gamma plus minus gamma into minus gamma, that is gamma square. Okay, into alpha beta, alpha into gamma minus alpha delta, then minus beta delta plus delta square. Alpha beta value we have minus q into minus alpha gamma minus beta gamma. Take minus gamma as common, we will get alpha plus beta, right, plus gamma square. Okay, into again alpha beta value minus q, alpha beta value, that is minus q. From these two, minus delta common, alpha plus beta plus delta square, minus q, and then next minus gamma into alpha plus beta value minus p, then it becomes p gamma. Alpha plus beta value minus p, already minus is there, that's why it becomes plus p gamma plus gamma square into minus q minus alpha plus beta value minus p into minus delta, it becomes plus delta p plus delta square. Now go for multiplication. Minus q into minus q square minus q into delta p minus pq delta minus q into delta square minus q delta square with q multiplication over. Then now we'll multiply with gamma p into minus q minus pq gamma p into delta p square gamma delta, and then next plus gamma p into delta square p gamma delta square, and then next gamma square into minus q into gamma square minus q gamma square, then next gamma square into delta p gamma square delta, then next plus gamma square delta square plus gamma square delta square. Then now you replace the values. Q square as it is minus pq delta, where we have delta, this is minus pq delta, this is minus pq gamma. From these two take minus pq common, then it is delta plus gamma, and then next here we have minus q delta square minus q gamma square. From these two minus q common, gamma square plus delta square, right? And then next comes to here p square gamma delta, p square gamma delta, and then next we have actually gamma delta value is there, no? Gamma delta value, gamma delta is equal to r, gamma delta is equal to r, we can replace it, p square r, then p into gamma delta square, p into delta gamma square is there, p as common, gamma delta square delta gamma square, we can take gamma delta common, here delta, here gamma, plus this is gamma delta whole square, gamma delta value we have r square, q square minus pq into gamma plus delta value minus p, then next minus q into gamma square plus delta square, we can write it as gamma plus delta whole square minus 2 gamma delta plus p square r plus p, gamma delta value r, gamma plus delta value minus p plus r square, then q square minus into minus plus p square q minus q of gamma plus delta value minus p whole square, that is p square minus 2 gamma delta value is r plus p square r, this is minus p square r plus r square, plus p square r minus p square r cancel, we'll get the value q square, here the remaining value q square plus p square q, here we'll get minus p square q plus p square q If you open the bracket here, minus p square q, minus into minus plus 2qr, minus into minus plus 2qr, and we have r square is there. Plus p square q minus p square q cancel. Then finally we got q square plus 2qr plus r square. Therefore, this is the value of q plus r whole square. This is the value of q plus r whole square. Then we will go for another problem. Before going to another problem, once we will see again this problem. See, alpha, beta are the roots of this equation. We got sum of the roots, product of the roots. Gamma, delta are the roots of the second equation. We wrote gamma, sum of the roots and product of the roots. Then he was asking the value of alpha minus gamma into beta minus gamma into alpha minus delta into beta minus delta. Multiply these two terms and these two terms are together. We will get the condition. There we have to replace. Here we will get gamma square plus delta square. Then that gamma square plus delta square can be expressed as gamma plus delta whole square minus 2 gamma delta. And where we required alpha plus beta, we have to replace, and alpha beta value, gamma plus delta value and gamma delta value. Finally, we will get the term q square plus 2qr plus r square, which is in the form of a square plus 2ab plus b square. Then we can write this one as a plus b whole square. This is the required value of alpha minus gamma into beta minus gamma into alpha minus delta into beta minus delta. That is the value, that is q plus r whole square. Now we will move to the another problem. If alpha comma beta are real, alpha beta are real, it is the important point here, you have to note it. Alpha beta are real and alpha square comma minus beta square are the roots of the equation a square x square plus x plus 1 minus a square is equal to 0, where a value is greater than 1. Then what is the value of b square, he was asking. What is the value of b square? Alpha beta are not the roots. Alpha beta are real and alpha square comma minus beta square are the roots of this quadratic equation, which is in the form of ax square plus bx plus c. Given alpha square, instead of alpha comma beta, he was given alpha square comma minus beta square are the roots. Minus beta square are the roots of a square x square plus x plus 1 minus a square is equal to 0. By using alpha square comma minus beta square are the roots of this quadratic equation, then what is the value of beta square, where alpha beta are real numbers only, they are not complex, they are real numbers. From this we can write sum of the roots, alpha square plus beta square, actually plus beta square, but here we have in place of beta we have minus beta square is there. That's why alpha square minus beta square is equal to sum of the roots is minus 1 by a square, minus 1 by a square, sum of the roots, minus b by a, that is minus 1 by a square, and product of the roots, alpha square into minus beta square is equal to 1 minus a square by c by a, that is a square, minus alpha square beta square is equal to 1 minus, this one we can write it as 1 by a square, I am going for separation, a square by a square, leave 1, minus alpha square beta square is equal to 1 by a square minus 1, 1 by a square minus 1. Now remove this minus, alpha square beta square is equal to, if we remove the minus, then minus into this one, it becomes 1 minus 1 by a square. Here we have minus 1 by a square is equal to alpha square minus beta square is there. Take this one as equation number 1. Alpha square beta square is equal to 1 plus, can I replace minus 1 by a square value as alpha square minus beta square or not? Alpha square minus beta square, since from equation 1 minus 1 by a square is equal to, we have alpha square minus beta square is there. Minus 1 by a square equal to, we have alpha square minus beta square. Now from this he was asking what is the value of beta square. Now 1 plus alpha square minus beta square minus alpha square beta square equal to 0. Take all the values to one side. I am taking alpha square beta square to right side, alpha square beta square to right side. Then go for the factorization. 1 plus alpha square we are keeping as it is. From these two I am taking minus beta square as common, minus beta square. Then it becomes 1 plus alpha square is common. If we take minus beta square as common, then we will get here 1 plus alpha square. Minus beta square as common, 1 remains here plus alpha square remains here. This is equal to 0. Then from this we can take 1 plus alpha square as common. Here 1 minus beta square is equal to 0. Therefore, either 1 plus alpha square equal to 0 or 1 minus beta square equal to 0. Alpha square equal to minus 1, then alpha equal to root of minus 1, which is not a real number. Therefore, 1 plus alpha square is not equal to 0. 1 plus alpha square is not equal to 0. Since alpha is real, if we take 1 plus alpha square equal to 0, then we will get alpha is equal to root of minus 1, that is nothing but I, which is not a real number, which is a complex number. That is a contradiction to the given statement alpha comma beta are real numbers. That's why 1 plus alpha square is not equal to 0. Then automatically what you have to take? Compulsory 1 minus beta square equal to 0. Therefore, beta square is equal to what, Nana? The value of beta square is equal to 1. What we did in this problem? We were saying that alpha comma beta are the real numbers and alpha square comma minus beta square are the roots of this quadratic equation. Then we have taken sum of the roots and product of the roots. There we have replaced alpha square plus beta, alpha square into beta square is equal to minus 1 by a square value from the equation number 1, that is alpha square minus beta square. Then we have taken all the values to one side and we formed a equation. Then go for factorization. We got the value 1 plus alpha square and 1 minus beta square. If we take 1 plus alpha square equal to 0, then alpha is equal to root of minus 1 we are getting, which is not a real number. Therefore, it is not equal to 0. Then automatically the second factor must be 0, 1 minus beta square. Therefore, beta square is equal to 1. See students, one more problem. If alpha comma beta are the roots of x square plus px plus q equal to 0 and x power 2n plus p power n into x power n plus q equal to 0, and if alpha by beta comma beta by alpha are the roots of this quadratic, this equation x power n plus 1 plus x whole power n is equal to 0, then n belongs to n, means where n is natural number, then n is in the natural number. What type of n we have? This n, whether it is an odd integer or whether it is an odd number or it is an even number or it is any number, any natural number or none of the value. That's what he was asking. Alpha, beta are the roots of this equation and this one. If alpha by beta, beta by alpha are the roots of this one, then where he was saying that n is a natural number, but in that natural number, n is a odd number or n is even number or n is any natural number or none of the value. That's what he wants to conclude. N is where n is what? Solution. By using this condition, alpha, beta are the roots of this one and this one, and alpha by beta, beta by alpha are the roots of this equation. then we have to find n is which type of number, whether it is the odd number or even number. Since given alpha, beta are the roots of x square plus px plus q equal to 0. Therefore, sum of the roots alpha plus beta is equal to minus p, and product of the roots alpha beta is equal to q. Okay. Another equation is given. Another equation. X power 2n plus p power n into x power n plus q equal to 0. This is given in terms of power n. Can I write this one as x power n whole square plus p power n into x power n plus q equal to 0. Now, put x power n is equal to t. I want to transform this one into again a quadratic form, x square equation. That's why I am taking x power n is equal to t. Then this becomes t square p power n into t plus q is equal to 0. Therefore, what are its roots? Its roots are alpha power n comma beta power n. Alpha power n comma beta power n. Then sum of the roots alpha power n plus beta power n is equal to, can I write minus p power n minus b by a minus p power n by 1, that is minus p power n, and if you go for product of the roots, then that is a q. Alpha power n into beta power n, we will get it as q. Now, from these two equations, we got these conditions, sum of the roots and product of the roots, and whenever this equation roots are alpha power n, beta power n, then alpha power n plus beta power n value, we got it as minus p power n. Now, if alpha by beta is the root of this equation, then n is what? Where n is what? If alpha by beta, you may take beta by alpha also, there is no problem. If alpha by beta is the root of x power n plus 1 plus 1 plus x whole power n is equal to 0. If alpha by beta is the root of this equation, then alpha by beta will satisfy this equation or not, is the 0 of this equation or not, which implies in place of x you have to replace now alpha by beta. Alpha by beta whole power n plus 1 plus 1 plus alpha by beta whole to the power of n is equal to 0. This one alpha power n by beta power n plus 1 plus, here the LCM is beta, beta plus alpha whole to the power of n is equal to 0. Alpha power n, for these two terms, LCM is beta power n plus beta power n. This is alpha plus beta whole to the power of n by beta power n is equal to 0. Now see, both are having the same denominator, beta power n. Then we can remove it. Then the LCM is alpha power n plus beta power n plus alpha plus beta whole power n is equal to 0. Now we have alpha plus beta is equal to minus p is there, and from equation number 1 we have alpha power n plus beta power n value is minus p power n is there. Now you replace those values here, this is minus p power n plus alpha plus beta value is minus p whole to the power of n is equal to 0. This is minus p power n, this is minus p whole power n. This is always negative. Power n is for p. This is the power n for minus p whole power n. This is always negative, but this is sometimes positive, sometimes negative. Therefore, when this sum becomes 0, now we have to check it. If you take n is equal to suppose 1, if n is equal to 1, then it is minus p, this is also minus p. Therefore, minus p, it becomes minus 2p is not equal to 0. If you go for n is equal to 2, minus p square minus p whole square, then it becomes plus p square. Here I am giving you the reason. If n is equal to 1, then this value is minus p. This is also minus p, that is minus 2p. It is not equal to 0. Why? Because here we have equal to 0 is there. Therefore, n is equal to 1, which is odd number, is not possible. If you take n is equal to 2, then it becomes minus p square plus minus p whole square. On the right side we have 0 is there. This is minus p square. Minus p whole square is nothing but plus p square. Therefore, minus p square plus p square gets cancelled. Then it is 0 is equal to 0, which is an even number. Therefore, when n is 1 odd, then it is not equal to 0. This sum is not equal to 0. If n is even, then this sum becomes 0. Even you can take not only 1, you may take 3 also. Minus p cube plus minus p whole to the power of 3. Minus p whole to the power of 3 is nothing but minus p cube, that is minus 2p cube. Is it is equal to 0? No, there is no chance. If you go for n is equal to 4, suppose minus p power 4, minus p whole power 4, minus power even number, then it becomes positive. Therefore, p to the power of 4 minus p to the power of 4, again it becomes 0. Therefore, this is possible. The sum becomes 0. It is possible if n must be an even number. N must be an even number. Did you understand now? Here n is a natural number, then n is which type of natural number he was asking. It is odd number or even number or any number. But it is only even number, then only this sum becomes 0. If it is odd number, then the sum is not equal to 0. I have explained here clearly with a example. Okay. Now we will go for the another problem. If x square plus x plus 2 whole square minus a minus 3 into x square plus x plus 1 into x square plus x plus 2 plus a minus 4 into x square plus x plus 1 whole square is equal to 0 has at least one real root, then the complete set of values of a is. See, observe this equation. First of all, it is not a quadratic equation. It is a biquadratic equation. Why? Because here we have x square plus x plus 2 whole square is there. X square whole square is there. Here also x square whole square is there, but both are different terms. This is x square plus x plus 2. This is x square plus x plus 1. Therefore, both are different equations. And this is a biquadratic, and here also we are getting the biquadratic, means if you simplify this total equation, we will get a biquadratic. Even here also x square into x square. He was saying that in that biquadratic means the 4 roots. Out of the 4 root, he was saying it has at least one real root. Means at least means it may have more than one real root. Minimum one real root, maximum 4 real roots. Why? Because it is a biquadratic, means it has totally how many roots? 4 roots. In that he was saying that it has at least one real root. then the complete set of values of A he was asking, not the values of X. He was asking the set of values of A, set of values of A. First, transform this given equation into quadratic form. Transform the given equation into quadratic equation form. Here we have x square plus x plus 2 is there. Here we have x square plus x plus 1 is there, x square plus x plus 2 is there. Here also x square plus x plus 1 is there. That's why I am put x square plus x plus 1 is equal to, I am taking some t. Means I am expressing this equation x square plus x plus 2 as plus 1 plus 1. Then we can take this one as t plus 1 whole square. Now it becomes a quadratic equation. That's the reason I am assuming x square plus x plus 1. Why? Because the same term here we have, and here also we will get, and here we have. That's why the common term we are assuming with some other variable t. Some other variable t. Now this equation becomes, since the given equation is x square plus x plus 2 whole square minus a minus 3 into x square plus x plus 1 into x square plus x plus 2 plus a minus 4 into x square plus x plus 1 whole square is equal to 0. Now with our assumption x square plus x plus 1 is equal to t, this equation becomes x square plus x plus 1 whole square minus a minus 3 into, this is as it is, but this one is changed as plus 1 plus 1, a minus 4 into, this is as it is, x square plus x plus 1 whole square equal to 0. Now replace x square plus x plus 1 as t. This becomes t plus 1 whole square minus a minus 3 into t into, this is t plus 1. Why? Because up to this part, plus a minus 4 into, this is directly t square is equal to 0. Now simplify this equation. Simplify this equation. T square plus 2t plus 1. T square plus 2t plus 1 minus a minus 3 into t square plus t. Right? This is a minus 4 into t square is equal to 0. Now separate t square terms, t terms and constant, means x square plus bx plus c, again quadratic form. T square into, here we have t square, that is 1, t square into this one, this is minus a plus 3 minus a minus of minus plus 3. Here we have t square, that is a minus 4, right? And then go for t coefficient. Then we are going for t coefficient. Here t coefficient is 2. Here t coefficient is minus of a minus 3, that is minus a plus 3. Here there is no t coefficient. And the constant is simply plus 1 is equal to 0. A gets cancelled. 3 plus 1, 4. 4 minus 4, 0. Means there is no second degree term. There is no t square. This one is 0. Now this is 5 minus a into t plus 1 is equal to 0. We got this one. Then from this, 5 minus a is equal to, we require the values of a. We require the values of a. That's what he was asking here. Set of values of a. 5 minus a is equal to minus 1 by t. 5 minus a equal to minus 1 by t. From this, minus 1 by t we are take it into left side, and a we are take it into right side. Therefore, we got a is equal to 5 plus 1 by t. if we get the values of t, then we'll get the value of a r naught. Then how we'll get the value of t? See, we considered x square plus x plus 1 is equal to t, where t is nothing but what? That is x square plus x plus 1. Therefore, what are its maximum and minimum value? What is its range? For x square plus x plus 1, always the expression is greater than or equal to 0, means it has the minimum value, the maximum value is always infinity. Why? Because here the coefficient of x square is what? 1. X square coefficient 1 is greater than 0. If the coefficient of x square is greater than 0, then always the expression has what? Minimum value. The maximum value is infinity automatically. Therefore, what is its minimum value? Minimum value is equal to 4ac minus b square by 4a or not? 4ac, a value 1, c value 1, that is nothing but 4. B square, b value is also 1, 1 by 4 into 1. Therefore, its value is 3 by 4. Therefore, this is greater than or equal to 3 by 4. Its value is greater than or equal to 3 by 4. Therefore, the value of minimum is 3 by 4. Maximum is infinity. Therefore, t belongs to, the values of t are closer to 3 by 4 to infinity open. Okay. Therefore, now we got the limits of t, that is closer to 3 by 4 to infinity. According to maxima and minima, it has the minimum value. Why? Because coefficient of x square is 1, which is greater than 0. Therefore, x square coefficient already we have discussed at the time of maxima and minima. When the function has a maximum value a less than 0, coefficient of x square is less than 0, it has a maximum. X square coefficient a is greater than 0, it has the minimum. Here greater than 0, therefore it has what? Minimum value. What is the minimum value? 4ac minus b square by 4a. From that we got 3 by 4. Therefore, its values are always positive. They started from 3 by 4. Therefore, t value is 3 by 4 to infinity, 5 plus 1 by close to 3 by 4 to infinity. Can we write 5 plus? Now, if we reciprocate, then the maximum becomes the minimum, minimum becomes the maximum, and 1 by infinity is nothing but 0. 1 by 3 by 4, then it becomes 4 by 3. It is closed. Now, add 5 plus 0, comma, 5 plus 4 by 3. 5 plus 0 is 5. 5 plus 4 by 3, 5 3s are 15, 15 plus 4, 19 by 3. These are the set of values of A. The set of values of A are open 5, comma, close to 19 by 3. The set of values of x for which the inequality step x square minus 5 into step x plus 6 is less than or equal to 0, where this step denotes the greatest integral function, means step denotes the integer function, greatest integer function, holds good for. I gave you the option. Why I gave the options we'll discuss later. The set of values of x for which the inequality holds good, means the values of x, he was asking where this bracket x denotes the greatest integer function. Based on this concept, already we did the problems mod x. Here it is a bracket x, step x. First you go for the normal factorization. First you find out what are its limits, means what are its values, the values of x you have to calculate. Then after we'll discuss about the integral function. We'll discuss about the integral function. The given inequality is step x square minus 5 into step x plus 6 less than or equal to 0. Go for factorization. 6 ones are 6. 6 plus 1 is 7, 6 minus 1 is 5, but plus 6 plus 1, that is nothing but here we should get the minus 5, therefore 6 and 1 are not the factors, 6 and 1 are not the factors. Therefore 3 2s are also 6, minus 3 into minus 2, that is plus 6, and minus 3 minus 2, that is minus 5. Therefore the factors are here minus 3 and minus 2, therefore step x whole square, minus 3 into step x, minus 2 into step x, plus 6 is less than or equal to 0. Now from these two, step x as common, step x minus 3, 2 as common, step x minus 3 is less than or equal to 0. Therefore step x minus 3 as common, we'll get step x minus 2 is less than or equal to 0. If you write in order, alpha should be less than beta. Here if we consider this one alpha and this one is beta, that is a contradiction to relation between the roots. Therefore one root must be less than the other root. That's why we have to write in order step x minus 2 into step x minus 3 is less than or equal to 0. See, this is in the form of, it is in which form, Nana? X minus alpha into x minus beta less than or equal to 0. Already we have discussed the sign of the quadratic expressions. If x minus alpha into x minus beta less than 0, where alpha must be less than beta, then alpha is less than or equal to x less than or equal to beta or not. Therefore x is lies in between alpha comma beta. X minus alpha into x minus beta less than or equal to 0, then x is lies in between alpha comma beta. See, this is in this form or not? X minus alpha into x minus beta less than or equal to 0. Therefore x is lies in between alpha comma beta, that is nothing but step x. Here instead of x we have step x is there, is lies in between the roots alpha and beta. This is the answer. Actually 2 less than or equal to step x less than or equal to 3. 2 less than or equal to step x less than or equal to 3, but in the options he was not given this value. 2 is less than or equal to step x less than 3 is given, but here we have less than or equal to is there, and 2 is less than or equal to x less than 4 is there, but here we have 3. 2 is less than or equal to x less than 3, here it is less than or equal to 3. None of these answers, none of these answers. See, 2 is less than or equal to x less than or equal to 3 is equivalent to 2. This value is equivalent to 2 less than or equal to x is less than 4. Why? What is the meaning of this, Nana? Step x will take the values 2, 2, 3 along with 2 and 3, along with 2 and 3. Means if we take according to the options less than 4, x value 2 less than or equal to x, means x will take the values to 2, and less than 4 means x will take the values less than 4 is nothing but x is equal to, up to less than 4 means up to it can take 3.9, 3.8. Step 3.9 is nothing but 3 or not, therefore it is equivalent to 3 only. No, that's why the meaning of 2 less than or equal to step x less than or equal to 3. Actually originally this is a value, this is the original answer, but in the options we don't have this value, means we have to check with the given options. Therefore 2 less than or equal to step x less than or equal to 3 is equivalent to 2. 2 less than or equal to x is less than 4 is equivalent to 2. Step x less than or equal to 3. Here I gave you the example also. Less than 4 is nothing but if we take x is equal to 3.9, then step 3.9 value is 3. If you take x is equal to 3.5, step 3.5 is again 3. Therefore it is equivalent to 3 or not? Less than or equal to 3 is nothing but less than 4. This is the value of this function.